Alright, for today's lesson, we're going to go ahead and move forward here and we're going to talk about linear equations and inequalities. Now, this stuff should be significantly easier than the function stuff we had to deal with the other day because I think most of us, for the most part, have a pretty good understanding of how single variable equations are going to work. Objectives, right here, pretty simple. We're going to solve linear equations and inequalities. Alright, these are just some definitions. I think everybody's pretty aware of what an equation is. An equation can be as simple as taking something like 2x equals 4. Alright, there's a variable, we have a constant, we have an equal sign. The key is that there's an equal sign involved in an equation. Alright, our goal is to move forward and find a solution set for the equation, which basically means we are trying to solve the equation for the variable that's there. Alright, now most of the equations that we're going to talk about right now are going to be referred to as linear. Most of us have graphed lines before, something in the form like y equals mx plus b. Well, we're not necessarily going to worry about the y part, but if we had like the mx, or in this case it says ax part on the other side, it would look similar to that. Now this is just an example of what some linear equations can look like over here on the left side. Alright, pretty basic, like I talked about before. What you'll notice is we only have one variable, and if something does not have a variable, it's just a simple constant, like in this case right here. Now on the right side of your screen, you will notice that the variables involved are accompanied by a square, for example down here, or a square root like I previously circled up at the top, or the x might even be an exponent. Okay, when that happens, we're no longer talking about linear equations, we're talking about square root functions or equations, quadratic functions or equations, or even exponential functions or equations. Alright, this is a chart that basically comes out of the book that I took this information from. Pretty much what we're getting at here is just the simple fact that if you're trying to solve for a variable, you're going to have to perform different operations. Alright, typically what happens is whatever operation is shown in the equation that you're given, you have to do the opposite to be able to manipulate something. So for example, if a particular equation involves addition, 2x plus 3 equals 6, in order to get the variable by itself, alright, I have to manipulate that equation by taking and subtracting the 3 from both sides to get it to the other side. Alright, and we'll talk a little bit more about that when we actually get into these equations. Alright, this I kind of alluded to already. Alright, when we're talking about isolating variables, we have to perform the inverse, or basically do the opposite of whatever operation is shown in order for us to get the variable by itself. Alright, this is just an example similar to what we had talked about the other day when we were dealing with functions, where you're given a scenario and you have to write a particular function. Alright, now I'm not going to get too much into how this is going to work, because on the next slide here it shows the setup for the entire thing. What we're getting at here is we're going to be given an equation or come up with an equation, and we're going to actually have to solve for the variable. So in this case, the company is charging a flat rate per month, plus you get an additional charge for every minute that you go past the allotted number of minutes. Alright, so if you're given a total charge for the month, we would be able to figure out how many minutes or additional minutes that we were charged for by solving for m. Alright, here's just another example. We're talking about stacking cups. Pretty much the same idea. You have a flat height right here based on what one cup is, and each additional cup stacked on top is going to add this much. We're going to be able to figure out how many additional cups we would get because we're given a final height. Alright, so pretty simple. If you're able to come up with an equation, we can also solve for the variable that's in question. Alright, this is a little bit more typical of what we're going to see today. You're going to be given an equation that involves one variable. Sometimes you'll see that variable written more than once. In this case, it's just there once. But we have to go ahead and solve for it or come up with a solution set for that particular equation. Now, in this case, there's two ways you could start by doing this. I'm going to go ahead and distribute. So I'm going to take the 4 times the m and the 12, which is going to give me 4m plus 48 equals negative 36. All right. Now we get to the point where I'm adding in here. So in order to get this variable by itself, I have to subtract 48 or perform the opposite operation to get that over to the other side. Again, the end goal is to isolate the variable. When I combine these over here, I end up with negative 84. My last step, since I have multiplication in here, would be to do the opposite. So I have to divide both things by 4. So in the end, m is going to be equal to negative 21. Now, if I wanted to, I could go back and fill that negative 21 in up here, all right, and prove that that is actually a solution. And what would happen in that case is when I combine everything on this side, it should equal the negative 36 that is on the other side. Now, the other way to work out this particular equation would be, rather than distributing right away, I can go ahead and divide by that 4, divide both sides by 4. All right, so in that case, I would be left with m plus 12 equals negative 9 after I perform all those operations. All right, the nice thing about that is it makes things a little bit easier to deal with. So I can just move straight forward by subtracting the 12, and I end up with the same answer. All right, now, it's not necessarily always going to work like that. For example, if this number, this negative 36, was not divisible by this number out front, you're probably not going to want to divide right away because you're not going to get a whole number, and we don't really want to work with decimals if we don't have to. All right, in some cases you're going to end up with equations where you're going to have the same variable, like in the last case we had x, but you're going to see it written on both sides of the equation. The process is pretty much the same. All right, we want to go ahead and isolate the variables. What we're going to have to do is pick a side to move them to get them together before we can do that. All right, so here's a good example. In this case, you actually see it written 3 times. So what I'm going to do is look at each side of the equation, and I'm going to go ahead and combine like terms or combine things that I can combine by looking at this. So I'm going to start on this side, left side. All right, and I'm going to go ahead and put those together, and I'm going to get negative 11. Okay, there's nothing to do with the plus 25, so that's going to stay the same. Now on the other side, the 2 and the negative 12 can be put together. So I'm still going to have negative 6k, but I'm going to have negative 10 written over here after everything's said and done. Now, like I said, the entire goal of this is to get the variables together on one side of the equation, all right, and then go ahead and isolate them, get them all by themselves. So in this case, I usually like to keep my variables on the left side just because that's typically how we read things. So I'm going to take and I'm going to add this 6k, the opposite operation, add it to the other side. Now some people do this in multiple steps. I usually like to do it all at once. So at the same time, I'm going to move this this 25 over to the other side by subtracting it. All right, so when it's all said and done, the 25s cancel over here. So I am left with negative 5k. On the other side, those are going to cancel out, and I'm going to be left with negative 35. Now my last step in this equation would be to perform the opposite operation to get the k by itself. So I'm going to divide by negative 5. And k is going to equal positive 7. Now again, you could go back up to the top with this solution and fill it in, and it should make your equation true if that truly is the correct answer. All right, the other thing we need to take into account is there's going to be certain situations in which we arrive in an identity or a contradiction. Basically what that means is in certain cases you're going to get all constants or all numbers to cancel out on both sides and be left with a situation where you have a variable equaling itself. In that particular situation you arrive in an identity, which means you could take the original equation and fill whatever you wanted to in for x, and it would always be a solution. So you're going to have an infinite number of solutions. Now sometimes you'll even arrive at something where everything cancels and you end up with something that looks like this: 2 equals 2, or it could be any number equal to itself. All right, same situation. That means that there's an infinite number of solutions. Now, on the other hand, sometimes all the variables will cancel out, and you'll be left with constants that arrive at something that looks like this, where you have 3 equals 5. All right, well, obviously 3 does not equal 5. You've arrived at a contradiction. What that means is that particular equation, whatever you started with, has no solutions. All right, so we're going to go through a couple examples of what this might look like. So again, getting back to the same idea we had before, I'm going to look at the left side of my equation and realize that those two are like terms, so I can go ahead and put them together, and I will get negative v minus 9. On the other side, I'm going to distribute that negative sign, so I'll get negative 5 minus v. Now you can kind of already see what's going to happen on this. If I have negative v on this side and negative v on this side, if I have the same exact thing on opposite sides, essentially they cancel each other out. So I will be left with negative 9 equals negative 5. All right, well, obviously negative 9 does not equal negative 5, so you would have no solution. You can write no solution if you want, and this would be referred to as a contradiction. If you did not notice that right away, once you started trying to move variables around, like say you decided to add v, it's pretty easy to see that this and this are both going to cancel out, so we'd be left with that same situation in the middle, which is no solution or a contradiction. All right, now it's pretty easy to tell if we went over a contradiction, we're probably going to take a look at what happens when you have an identity. So I'm just going to start this by distributing 2x minus 12, and on the other side I can combine the negative 5x and the 7x, all right, and get 2x minus 12. All right, well, in this case already, similar to what we had on the last one, I have the exact same thing written on both sides of the equation. So basically this side and this side are going to cancel. I will be left with 0 equals 0, which is in fact true. And what this is telling me is I have an identity, and that I could fill any number in for x in the original equation, and I will get the solution to work out, or I will get the equation to be equal to the other side. Had you not noticed this right away and you started moving numbers, say you decided to add 12 and add 12 over here, well, you can see that the 12s would cancel out, so you'd be left with 2x equals 2x. At that point, you'd probably be able to notice that you had an identity, and you could say that you're going to have an infinite number of solutions, or sometimes people just write many solutions. It basically means the same thing. All right, again, that is what an identity will give you. All right, the last thing that we need to talk about is inequalities. Now, basically, the whole idea of an inequality really isn't that far off from the idea of a equation. The only thing that's different is you're going to have inequality signs as opposed to equal signs. All right, the other operations that you perform are going to be very similar to what we were doing with equations. The only difference is instead of arriving at one number that was going to be your solution, you're going to have a range of numbers that can be your solutions. Real quick, just to kind of review a little bit, this is a less than sign, greater than sign, less than or equal to sign, greater than or equal to sign. Right? And when we get into the examples here, I'll explain a little bit more as to what those actually mean. Okay, again, this is just something that comes out of the textbook that I pulled this material from. The main thing you need to be aware of when you're talking about inequalities is the fact that if you ever multiply or divide both sides of an inequality by a negative, you have to switch the direction of the inequality sign. All right? Because basically by multiplying or dividing by a negative, you have changed the order of that particular inequality. And if you don't switch the signs, you will end up with the wrong range of numbers as your answer. All right, now just to make sure, sometimes it's easy to forget to do that. It's never a bad idea to pick a number from your range, your solution range, and fill into your original inequality to check to make sure that you didn't make some type of mistake along the way. All right, so here's an example. We're going to solve these and graph these. Alright, so in this case, again, I'm going to try to keep my variables on the left side if at all possible. So I'm going to go ahead and subtract this 13a over. And at the same time, I want to get this 2 over to the other side. So I'm going to add it. And again, that's just me saving steps. If you want to do it as 2 separate steps, you're more than welcome to. I'm going to get negative 5a on this side. It's greater than or equal to 10 on the other side, because these quantities are going to cancel each other out. Now you can already see what we talked about. I have to perform the opposite operation here, which would be divide by a negative 5. Alright? I will get a on this side, but I have to change the order of my inequality. Alright, so I switch the direction of the sign, and I arrive at a is less than or equal to negative 2. Now when we graph these, we're just going to graph these on a number line. I don't get too carried away with what numbers you have in your number line. The most important one would be the number that actually shows up in your inequality. In this case, negative 2. Now, we're going to have a range of answers, as we can see up here. Anything that is equal to negative 2 or less than that value is going to be a solution to the inequality we started with at the top. Alright? Now, because we're including negative 2, we have to put a filled in circle on negative 2, signifying that it is actually an answer. Alright, and then we shade our number line to the direction our inequality tells us to. In this case, anything less than negative 2 or to the left of negative 2. Now, had this been a is simply less than negative 2, our number line would have looked a little different, because now negative 2 is still our marker, so to speak, on the number line, but it is not actually an answer, so we would have to put an open circle on it and then shade to the left. So what that tells us is that any number that is less than negative 2, not including negative 2, would be a solution if it was just a less than inequality. All right, again, it's never a bad idea, once we get our solution over here, to pick a number, say for example like negative 3, and go back and fill it in to our original equation up top, just to make sure that our inequality makes sense after we get done with it. Here's another example. I'll just kind of buzz through this one real quick. Again, I'm going to subtract 4x from both sides, and at the same time I'm going to move this 8 over there, so I'm going to subtract it over to the other side. I'm going to be left with a negative 3x is greater than or equal to 9. Again, I end up dividing by a negative, so x, I have to change the direction of the sign, is going to be less than or equal to negative 3. Alright, again, number line is very simple. I take that number that's listed in my inequality, I put it in the middle, I take and I fill in my circle because it is a less than or equal to, and then I shade in the direction that is represented by the inequality that I found. Again, if you feel the need to, you can check your answer, pick a number off of that particular range. So like for example, if I pick negative 4 and I was going to fill negative 4 in place of my x's, negative 4 in this case, negative 4 times x would be negative 16 plus 17. So on this side I would end up with 4. It's supposed to be greater than or equal to on this side, I would end up with 1. Alright, that makes sense. That means I probably have the correct inequality listed as a solution set for the answer. Alright, homework is just going to be a worksheet that I put together that's available via my website. I've also printed off some hard copies for the class, but you can always refer to my website if you need to or have any questions about what the assignment is supposed to be. Alright, I think that pretty much clears up everything that I need to discuss for today. If you have any questions, please make sure you come see me and ask about them.